My name is Taylor Liu, and I'm here to do the homework 3 problem 1 for the probability course. And you can see my share screen on the monitor. And let's see the problem 1. For the problem 1, we have a probability of x equals to k with the sorry, it's not internet is not working that well. With the b multiplied by k by p with the power of k minus 1, and k equals to 1, 2, and to the infinity, with p is greater than 0 and smaller than 1. So firstly, we need to realize that there are something containing in this problem is that the sum of the geometric series. So let's see. The point is about this one. This is the sum of the geometric series that we will use for this problem. And the point is that to build up the possible probability function, we need to use this as the tool to help us prove that. So let's see the problem A. We have the find B so that P probability x equals to k represents a probability mass function. So what do we have now is we have this one, right? But we have to remodify it because the k starts from 1 instead of the 0. So we will have the k starts from 1, pk will equals to 1 minus p minus 1 minus p0, which is the 1 minus p over 1 minus 1, right? So it's kind of obvious. And now we have the probability of this one sum, and then how did we get the k multiplied by p over the order k minus 1? Well, it's kind of like using the derivative to do that differentiation. So we can see that for this one we'll have the differentiate by k, and we will have the right side of this one is 1 minus p minus 1 minus 1 over p, right? So for the left side, we will have the k equals to 1 to infinity, so k multiplied by p over the order of k minus 1. Okay, this is what we want, and for the right side, we will have the based on the calculator, it will have 1 minus p squared over 1, or 1 over 1 minus p squared. And here is the equation that we can use for the first step. And then we can see that for this problem, we have the bkp over k minus 1. And with this function, we will know that for the k starts from 1 to infinity of this function, actually equals to 1, right? Since we need to find the represents the probability mass function, the sum of all the elements of the probability mass function is equals to 1. But now we have this one, so if we move it to left side, from left side to right side, to right side to left side, it is 1 minus p over square multiplied by k by p with k minus 1 power, and then we have is 1, right? We just satisfy this function. So we can get b equals to 1 minus p squared. Yep. So that's it for the problem A, part A. And then we have the part B. Part B is to find the expected value of the x. So expected value of the x. What is the expected value of the x? We can write it in formula, which is k equals to 1 with the infinity and k multiplied by power x equals to k, right? That's the probability of the expected value of the x, and we have right. That's it for the problem. So we need to solve this. We have to modify it first, which is to make it simple to solve, which is pk minus 1, right? Yeah, that's answer here. And to do this problem, we need to do it furtherly. To use which one? To use this one. To use this function. Thus, for this function, we have k equals to 1, infinity k, pk minus 1 equals to 1 minus p squared over 1. And we modify it, we will have the we'll have the left side to do remodify first, which is k equals to 1 to infinity, and right, this is to get the p with the order of the k instead of k minus 1, which is make it simpler to solve. And we can move the p with the order of -1 to the right side, which is the which is the 1 minus p squared with the p over it, right? So then do the differentiation again. By calculation, it comes out like this. So now we have this one. What do we want here? We want this one, right? So multiply it by 1 minus p squared. We will have one minus p over with 1 plus p. So this is the answer for the problem B, and for the C. We need to solve the ex squared, expected value of the x squared. So what do we need to do next? We still have to dealing with the differentiation part. Like we have it here, right? We have the k equals to 1 to infinity, k squared is power of k minus 1, and which is 1 plus p over 1 minus p is order of 3. Then do the same thing. We move out the k minus 1 to 1 with p minus 1, right? And move it to the right side. And we will have 1 minus p result of 3. Top it will be 1 plus p divided by p. And do the differentiation again. And the right side by the calculator, it comes out to be this one. Let me check it. Yes, so now we have this one. So why we need to have this formula here? What is to do with the expected value of x squared? So think about the x squared, expected value, which is the sum of k equals to 1 to infinity to the k squared multiplied by x equals to k, right? Which is k equals to 1 with the 1 minus p squared. Right? This is what we need to find. And now we have this one. This is what we have to find. And now we have this one. Right? So it's obvious that this one will be 1 minus p squared over p squared plus 4p plus 1. So this is solved for this one. And the next one, actually it's kind of simple. We just need to right, this is a problem, and we only need to turn it into this one. We have 1p over 4 p squared plus 4p plus 1, and the minus e squared, which is the 1 minus p squared, and 1 plus p squared, which is the top is the 1 minus p squared for the p squared plus 4p plus 1 minus 1 minus 2p minus p squared. P squared 1 only with the 1 minus p squared over 2p, right? This is the answer for the part D. And the last part E, it asks us to p equals to 3 over 1 or 1 over 3. We need to find the probability of conditional probability mass function. So now we have the p x equals to k with x larger or equal to 2 and less or equal than 5. And for this problem, we need to use the this formula, which is the problem is that we have to find the probability of the x larger or equal to 2, x from 2 to 5, and the probability with x equals to k, and x goes to 5. So how to calculate this? This is actually turns out to be this one, right? Turns out to be k equals to 2 to 5 with the probability x equals to k, right? So we can bring it in. Yeah, I think it's equals to k equals to 2 to 5 with the 1 minus p squared divided by k by pk minus 1, which is 5 2 over 3 squared multiplied by k by 3 over 1 k minus 1. And by the TI Inspire calculator, I calculated, and find out it turns out to be, this one turns out to be 392 over 729, and turns it out to be here for this one multiplied by x equals to k. Oh, excuse me, did I make something wrong? Oh, no, that this is right. Equals to take x larger than or x from 2 to 5, right? So this one what turns out to be 392,729 multiplied by 1.4 k by 3 over 1 k minus 1, which turns out to be 0.826531 multiplied by k, and 3 over 1 k minus 1 with k equals to 2, 3, 4, 5. So that's it for the problem E, and that's it for the whole problem of problem 1. We have all solved. Thank you.